already checked, I've already covered our books during Flex today. I'm going to come around and check homework, but while I'm doing that, I want you guys to take some information here, and I want you to create a histogram from it, okay? So I'm going to just kind of show you what I'm looking at here. And you have, don't worry about the cumulative frequency yet, because we'll get to that in a few minutes, but I want you to create a histogram. We know what that means. We've created those before, where you have some bins from 10 to 20, 20 to 30, 30 to 40. You know how to label those axes now. That's part of that part 1 of the univariate data that you guys did, and I already graded and turned back to you. And then those are the frequencies. Make sure that you use your graph paper. Make it on the top half, because we are going to make a different graph on the bottom half of the graph paper. Use the ruler that I gave to you so you can make straight edges and nice, neat axes. Make a title, label with units, etc. And then I'm going to come around and check homework while you guys do that, okay? So we're going to come back to the histogram in just a minute, and you guys can continue to work. But let's look at the homework. I actually graded this for extra credit. Okay, this was the variables 3. So if you want to get that out, let's just kind of check our answers here. What I ended up looking at were the graphs. And on these graphs, I have only one that is skewed left, if you look at the histograms. So which histogram is skewed left? D as in dog, right? So if you look at histogram D, it's skewed left. Which of the box plots is the only one that's skewed left? 1, because it has that long whisker to the left. So that's the one that I graded for extra credit. Did you actually tell me that that should have been histogram 1? If you got that right, and you did everything else, I gave you a 6. Okay, so it's just something that I'm looking at to grade. Let's make sure we understand the rest of it, though. Which one do you think is histogram C? It looks like it's heavily skewed right, maybe with an outlier or two, not really sure, hard to guess, but if we had to, this one would have outliers over the other ones. And so since one of these box plots has outliers, what would you say histogram C matches to? I would put 4, because it's definitely skewed right with a couple of outliers. So to me, that is histogram, or box plot 4. Okay? Now the first two are a little bit different. Okay, they're neither really heavily skewed right, nor are they heavily skewed left. So we can't really look at skewness on those. And if you look at the 2 remaining box plots, 2 and 3, I don't really see a heavy skew in either of those either. So what else can I look at? Well, if I look at the histograms, the difference between them is that histogram B is more squished together in a mound shape, and histogram A is more kind of spread out. So when I say those words, squished together and spread out, what am I looking at? The spread of the data, right? The spread. So I could be looking at IQR, I could be looking at range, I could be looking at standard deviation. But if we're just talking about spread in a general sense, a spread in histogram B, is it going to be smaller or larger than the spread in histogram A? Smaller. More squished together, more tightly around the center means a smaller standard deviation. So we know histogram B has a smaller standard deviation. Which box plot between 2 and 3 has a smaller? Box plot 3 has a smaller box. Would you agree? So the smaller IQR. So I agree. So I think that B should be 3, which leaves me this to be 2. How many of us got all of them right there? Yay! Good job. You know what I really liked about Sam, what she did? She actually wrote the justifications about why she chose which graph. That's awesome. So AP wants us to be able to communicate with them about why we did what we did. So that's a really important and useful thing to write down and do. I didn't ask you to do that, but that's such great foresight, so that was awesome. Okay? Let's go ahead and look back at the variables 2 now just for a second. Are you guys going to be opposed to me turning the fan on in here? Don't oscillate it. Point it at me. At Boris. Are you going to be freezing if I turn it on? Because I'm HOT. Okay. And not in that like sense. Because I'm not vain. Here we go. All right. So if you look at, did we go over this one in its entirety last class? Okay, we did. Just want to make sure that we did. So we've already answered that. Perfect. All right then. What I'd like us to do is come back to this idea. I'm going to move something. Oh, you know what we should do? Let's look at the second part of your homework briefly. We'll come back to those histograms in a moment. But the second part of your homework, that part 2, kind of had you do a little bit of an investigation about what happens to the mean, the median, the IQR, I believe the maximum minimum values maybe, when you add number or multiply numbers. Okay? So I kind of wanted to do a little visual in class today, but I need 5 volunteers. So any 5 people, if you want to come up to the front of the room, I'm going to hand you a whiteboard and a marker. When I hand you that, if you would please write the number of on the whiteboard for me. I can find my whiteboard markers. They're here somewhere. Come on up. Don't be shy. Just come. So what I'm going to ask, and everybody needs to pay attention and watch up here, okay? I'm going to ask my volunteers if they would kindly go ahead and line up as if the front of the room was a number line, and in order and space it out, number yourselves and arrange yourselves in the front of the room. Hold your number in front so it's pointed to us. Byron, do me a favor, since you're 0, go all the way to the left for me. And then we're going to kind of space yourselves accordingly and accurately to what you see. All right. So let's kind of, maybe we should judge their decisions. Do you think that they're lined up the way they should be? I'm going to say no. I agree with the no. What's maybe wrong with the way they're lined up? Say it louder. 6 and 12 are way too close to each other. So I know. Here, we're going to have to bend our number line because the cart's in the way. So why don't we just come like through the classroom? We're going to pretend like it's a bent number line. Sorry about that. All right, that's good. Still, what do you think? I still think 2 and 3 need to be closer to each other. So maybe I can have Jessica and Boris kind of, Boris, you stay closer. I think that's about right. I think do you agree with me? I think it's to scale, we'll say. All right. So if that's to scale, we're going to do this, and we're going to have everybody who has a whiteboard, if you would please, go ahead and cross your original number out, no need to erase it, and add 2. So leave your same number on there, cross it out, add 2. Okay, everybody add 2. I know, hard to write upside down, I get it. Okay, and then at the same time, we're all going to move on our human number line to the right too. So I want everybody who's at the same time, we're going to do it. I want everybody to kind of visualize this for a minute, and everybody take 2 steps to this way, right? Ready? 1, 2. All right, so stop. What changed in terms of the summary statistics? Summary statistics might include minimum, maximum, measure of center, spread. What do you think? The minimum and maximum changed. What happened to the minimum and maximum? They went up by 2. So those values changed. What else changed? The median, or the measure of center, changed. It also went up by 2 because the center moved with everybody when they all moved to the right too, right? What did not change? The range. The IQR, the range, any measure of spread did not change. Think about measure of spread, just a visual representation. Didn't this whole group all together do this? The spread did not change, did it? Okay? Perfect. So go ahead and erase what you multiplied by back to your original number. And we're going to do one more thing. So that means everyone take a step to the left too again. Go back to your original spot, human number line. And now we're going to multiply by 2. So take that original number and multiply by 2. Okay? Now this one we're going to have a little trouble all doing exactly at the same time, but attempt, I'm going to say 1, 2, 3, move, and everybody move to where you think the human number line, where your number would now be. 1, 2, 3, move. Make sure you're to scale. Awesome. All right, so let's talk about what changed here. When I took our numbers and I multiplied by 2, did the center change? Yes. Okay. Did the spread change? Yes. As a matter of fact, everything changed except The minimum didn't change because it was 0, okay? But if it was anything other than 0, like a 1, I mean anything, it would have changed as well, right? It's just because the 0 product property, when you multiply by 0, it just stays 0, okay? Huh? No, you went from 2 to 4. Oh, that's a coincidence. It's because 2 times 2 and 2 plus 2 is 4. That's the only reason for that. All right? So when you multiply, what changes? Everything. When you add or subtract, what changes? The range doesn't change. The median changes. So when you add or subtract, only the measure of center changes. The spread does not change. Thank you, everyone. If you would go ahead and just put those right back on the cart for me. Good job. Let's give them all a round of applause for participating. Great job. So I've already mentioned that you will have a test next Thursday, and we will review on Tuesday. We're going to kind of be finishing up and closing some loose ends today. This, what you do by adding, subtracting, how you affect a distribution of numbers, what measures get changed, what statistics change, is a question you'll see on your test. Okay? So it's important to know that part 2, what changes and what doesn't change when you do those things. Okay? So definitely on your test.
What day is it?
Next Thursday. All right, so let's go ahead now and look at that graph that I asked you, excuse me, to create. Oh, not that one. Where was that graph? Let me see if I can find it. I think I moved it. There we go. I asked you, shh, I know it's a Friday before a weekend and we only have about an hour left of class, but we still have time. So we need to work on some more things. So I'm asked you to create a histogram on the top half of your graph paper using this information, okay? So as I come around, I'm noticing that some of your axes are not labeled properly. So your horizontal axes must be labeled. Nope, horizontal axis is labeled. Nope, centimeters. Use the unit in which you're measuring, okay? So the unit in which you're measuring, it's okay to say length, but you also must say centimeters, okay? That's perfectly fine. I actually prefer that, quite honestly. Length in centimeters, perfect. So if we're going to do that, we're going to go ahead and create our axes here. We are going to use straight as line as we possibly can. We're going to label them. Length in centimeters. Looks good to me, James. Okay. How do I label my vertical axis, Catherine? That's your frequency. Remember, it's okay to put relative frequency along that axis as long as we label them as what? Percentages. So either one is okay. We weren't given percentages, so we're not going to use percentages, but you could. So let's go ahead and decide how we're going to numerically address the axes. Let's start with the horizontal and our centimeters. This is what I don't want you to do. Why do I not want you to do that? That's not, because we talked about not doing that a couple class periods ago. When we had our post-it notes, if you remember, we said don't do that. Here's what you should do though, okay? So we're going to say that I'm going to go up by, how does it goes up to 100, doesn't it? It goes by tens. So I'm just trying to figure out if it goes by tens, if I say maybe 10, 20, 30, 40. I'm hoping this will be big enough. I think it will. 60, 70, 80, 90. We'll go out to 100. All right, you good to go? How do we feel so far, okay?
Great.
All right, I like that. Great. So now what we have to do is label our axis numerically on the vertical axis. What is the frequency? What's the largest frequency we have to go to? 16. So we need to make sure that we go up to 16. We're going to do that. Just made it. I'm still missing something before I start actually making my bars for the histogram. What should I include? The title. And these, I believe, were plant heights in centimeters. Okay. So we'll label that as well. Okay. It's only until now that I'm ready to go ahead and create the graph itself. I had to do all the setup work underneath it. From 10 to 20, I have a bar of a frequency of 1. So we're just going to go up to 1 here, make our bar. Then we have, what, 1, 5, 7, 9. So I'm just going to go ahead and go in that order, if that's all right with you guys. Yes, dear? So that's a really good question. Did everyone hear what Zachary asked? Does it matter what the title is? The title needs to be in context. So obviously you can't write the word title up there. People did it. Don't laugh. Okay? People labeled this boxes, or bins, groups. Well, that's what they are, but I want the context. Okay? So if you wrote lab plants, or, as long as it's context, I'm okay. Okay? All right, so what I say, 1, 5, 7, I think it went up to 9, correct? There we go. So 1, 5, 7, 9, 10, 16, 14. So 10, 16, 14. My last bar got a little ahead of me there. And then what were the last two? 10 and then back down to 8. All right, so we have 10, and then our last bar should be down here at 8. Okay. How'd we do? Did y'all do the same thing? Can we create a histogram? We should be able to, right? So I have a question for you. What's the IQR? Is it easy to find the IQR? Is it possible? Yes. This graph doesn't lend itself to answering that question very easily. We could count. We know that there were a total of, we know the total of plants? We could add up the total. It was 80, by the way, right? And then we could figure out where the 20, well, why am I saying 25? What does 25 have anything to do with anything? What does 75 have anything to do with? Q1 is 25%. Q3 is 75%. Would you agree of the data? So those percentages are going to come into play. Here's what we're going to do, though. We're going to create a different kind of graph to answer the question. It's called an ogive. Say that kind of fast. Okay? Ogive. Kind of reminds me a little bit of the band I saw this summer. I went and saw Earth, Wind, and Fire at Jiffy Lube this summer, and I definitely did some jiving then. It's fun. But it's called an ogive. I think the most ogive, that's how you spell it, by the way. The more common term for this type of graph is called a cumulative frequency plot. Okay? And so this is the second graph that you're going to create. So you're going to create an ogive, which is a cumulative frequency plot to answer this question. Okay? So what we have to do is go back to our chart, and we have to fill it out completely. We already know how to do a histogram. We only needed the bins and the frequencies. But to create this graph called an ogive, or a cumulative frequency plot, we need the cumulative frequencies. So how does that happen? What does that mean? Well, it means that they should all be a total of 80, because if it's cumulative, it includes everybody. And we're going to keep adding as we go. So the first frequency was just 1. But if I take the 1 and I add 5 more, how many do I have now? 6. And if I take that 6 and I add 7 more, how many do I have? 13. So let's keep going, and you add. I'd like this chart to be somewhere on this paper as well, so you know where these numbers are coming from. And let's go ahead and fill out the cumulative frequencies here. So I'm going to go ahead and add up to get my cumulative frequencies. Hopefully you've done this as well. 13 and 9 should give me, I believe, 22. We add another 10 to get 32. We add 16 to get 48. We add 14, we should get 62 again, 72, and then another 8 gives you 80. So those should be the cumulative frequencies as we go along. Sometimes they ask us for cumulative relative frequency. What's a relative frequency again? The percentages. So sometimes we would be asked to put percentages here, but I'm not going to do that today. Okay, you guys did that on your part 1 of your summer assignment, that univariate data. You did the relative frequencies. You found the percentages. But for here, we're just going to deal with the counts. Okay, so what I'm going to do is on this ogive, I'm going to create an axis again. But this time, what I'm going to be graphing are obviously those cumulative frequencies. And then we're going to have the same bins that we had before. Okay? So we'll go ahead and create our axes one more time. We'll have our cumulative frequencies this time on the vertical axis. We should label it as such. If it is cumulative, please label it. Helps if I can spell. So cumulative frequency. And then down at the bottom, what should we label it again? Plants, heights in centimeters, right? We've got to make sure we're using our unit of measure. You can also say length, I would accept that, but the unit that's important is your centimeters. I believe that's what we measured it in. Before I start graphing anything, I'm going to title it. I'm going to say an ogive of plant heights. Yes, love? An ogive is a cumulative frequency plot. It's another name for it. Same thing. It's the first time you've ever seen it, so we're going to graph it together. You're not sure what it is. Okay? We're graphing it now, though, and I'll show you what we do. So I need to label my axes. Again, my bins went from 10 to 100, so I'll do the same thing again. Oops. And then the cumulative frequencies went from 1 to 80, right? So I'm going to go by tens again. So I've labeled my axes appropriately. I've given them in terms of units. I've numerically numbered them. Now I'm ready to actually start plotting and putting the points on the graph. You're actually going to be doing points this time, not bars. A cumulative frequency plot looks more like a line graph than it does a bar graph. Okay? There's no bars. And we're going to be measuring or writing down these cumulative frequencies. So we're going to start at 1. So from the dots, I'm going to make my dots red. And at 10, we're going to be down here at 1. So do I put it in between? That's a really good question. Should we put it in between 10 and 20? Sometimes people ask you to do that, but I'm going to put it on the 10 only because it's the left-hand hash mark. It's not wrong either way. Okay? You want to put it in the middle because it's somewhere between 10 and 20? We're not sure? That's fine. You can do that. Okay? All right, so between 20 and 30, what was the plant height? Up to 6. All right, between 30 and 40, 13. I'm going to show you what to do with the points in a minute. Between 40 and 50, 22. 50 and 60, 32. 60 and 70, 48. Between 70 and 80, 62. 80 and 90. Put this over here so it's not in our way. I'm sorry, was 70 what? 72. All right. And between 90 and 100, obviously we're at the 80. Okay? So I have these series of dots. Now here's an important thing to know. Do not connect them with straight lines. An ogive is meant to be a smooth, fluid curve. It's continuous. So that's what we're going to do. We're going to take this and we're going to make a nice, smooth, fluid, and it really should have somewhat of an S shape. Ogives tend to have an S shape to them. This one's not a very pronounced S shape, but you do want to make it it's not very S, like I said, it's not very pronounced, so this one should kind of go up more like that. Okay? And again, it's approximate, right? All right. So this is the cumulative frequency. It's always going to increase because we're adding more every time, right? It's cumulative to get to our total of 80 plants. And we're going to come back to the question, what's the IQR? Okay? Because that's the question I'm going to ask. So, what information do I need to answer the question? I need to know what quartile 1 is and what quartile 3. All right? So let's answer those questions. Quartile 1 is something and quartile 3 is something. If I wanted to ask you, well, let's just start with quartile 1 and quartile 3. Quartile 1 is associated with what percentage? 25%. And remember how I said earlier that sometimes the relative frequency is graphed here, which you'd already have percentages here? That would be kind of nice, wouldn't it? Because you could go to 25% and be done. So that's why that's helpful. So if we don't have the percentages graphed here, we have to do that ourselves. It's like an extra step. So let's find the 25th percentile. Here's where you need a calculator. Maybe you can do it in your head. I don't know. 25% of what? 80. Perfect. There are 80 plants. What's 25% of 80? 0.25 times 80. 20. So what you're going to do with your ruler, you need to make sure you have a ruler, or if you want to use the corner of something, like the corner of a piece of paper, but what you're going to do is this. You're going to take a straight edge, and we're going to go over here on the left-hand side to 20. I'm going to make mine green. And we're going to go until we hit the graph. And then we're going to stop. It must be exactly horizontal. And then, yep, make a line on your graph. And then from where it hits the ogive, we're going to go perpendicular to the horizontal and go straight down. And that green part of the graph, or it's not really part of the graph, it's what we're using to find the percentile, is how we find it. Yes? Question? Why did I go from 20? Because the first quartile is 25% of 80. 80 was the total, right? 25% because it's quartile 1 is 20. So I started 20 here. Okay? Zachary, if this was already in percentages, I just go to 25%. But I define the 25% first. Now, is quartile 1 20? No. Quartile 1 is about 42 or 43. The numbers that you're going to give me are always on the horizontal axis. They're the centimeters. It's what's measured. Okay? So quartile 1, I'm guessing 43. What do you guys think? About that? All right. Now let's find quartile 3. That's 75%. What's 75% of 80 is 60, right? So we're going to come up here to 60, where it hits the graph. It's going to a little bit if, yes, it would, wouldn't it? Okay. In my first class, I did it on the left-hand side. Let me research that because I think you're right. It's going to make a big difference depending on whether or not whether we move it to the right or to the center. You mind if I look because you can do it either way. Okay. And so it depends on, and honestly, yours actually might be a little different because so I'm probably never going to ask you to create your own. I will always give it to you, and because that way everyone's is exactly the same. I'm more concerned that you know how to find the quartiles given an ogive. But I still want to answer your question because I still think it's a valid point. So let me look that up and get back to you, okay? Good point. So back to quartile 3, we're at 60. We go where it hits the graph, and we're going to go down perpendicular. Mine looks to be about 72, I think. 73. One or two off, and either direction is going to be okay. It's an approximate answer here. So we're looking for 75% of 80, which was 60, and that's going to be Q3. So we're going to write Q3 here. And then obviously we're going to subtract those to find the IQR. What's the IQR? It's going to be 72 minus 43, which is 29. Could you tell me what the median was? What would you do? 50%. I'm not going to go to 50. I'm not looking for the number 50 over here. These aren't percentages. What's 50% of 80? 40. So I would go to 40, and that would be the median. Because I had to multiply them to figure out where the frequency was that I'm looking at. And then the numbers down here are what the quartiles are. So I had to use this 20 to come over here and come down here. 42 was the quartile. Okay? Any other questions? On your homework that you're going to be asked to do, you're going to be given the ogive. And actually, on any test or quiz, I would give you the ogive. So next Thursday, expect an ogive. Could you then maybe draw a box plot from it? If I gave you an ogive, could you draw a box plot? What do you need to draw a box plot? You need a minimum? What's the minimum here? 1, right? The minimum? No, that 1's not the minimum. I'm a liar. It was somewhere between 10 and 15. It's a matter of not knowing whether it was 10, 11, 12, 13, 14. You know, it's somewhere between 10 and 20, right? The minimum was somewhere here in this range. The maximum was somewhere over here in this range. We can't be exact. It's a range issue. Okay, that's what Elena kind of brought up. So what I would like us to do is look at something where I asked you like this, where there's no ranges anymore. Okay, could you now find, or could you now do the 5-number summary? You'll have to do that. So let's practice. What's the minimum here?
0.
No. You're never using those numbers here. You're always answering these questions using these values. So what's the minimum? 30. Very good. What's quartile 1? We have work to do. So let's come back. We'll do quartile 1, median, quartile 3. What's the maximum? 100. So I have some work to do to find the 3 quartiles. Okay, quartile 1, what's 25% of 60? So I'm going to go to 15. I'm going to go to where it hits the graph, and then it looks to me like it's about 60. And now I'm going to go and we're going to find the median. What's the median?
30.
I'm going to go over to 30, come all the way over here, and looks like it's going to be about, 70, more than 71, 22, because it went down here. I didn't highlight it in red, sorry. Because it 1015 over, looks like it hit about 60. Okay, good. So I'm going to say 72. And then we have to find the last one would be 45. Go over here, go down. About 87, 88. Either way, it's not going to be too, I'm not going to count off if it's wrong. And we do our box plot. You will have to do that for homework, okay? In your textbook, you'll be given an ogive, and you'll be asked to find that information. I can see it happening on your test next week, too. Okay? Next Thursday. I said it a couple times now. You have a test next Thursday. Yes? Okay, I'm not going to do it one more time because I've recorded it, but at home you can definitely watch it one more time. Okay? So that's the whole point of doing that. But again, what you're looking for, Cameron, is 25% on the left-hand side. Find the 25%, go over, and answer it down here. Okay? All right. Last thing I want to talk about is something that I want you to use your calculator for. So if you would get your calculator out, if I asked you to find the mean, different than the median, different than the whatever, this would be hard to do here. But what if I gave you a data set that looked like this? Maybe. My smartboard is red again. All right, guys, last thing. Let's look. Here we go. So, this one I just kind of want you to look at. Shh, no need to write it down, but you do need a calculator. And I want us to find the mean. Okay? I'm just worried about the mean. I want us to find x bar. Find the mean. Read the problem first, and let's figure out how we can use our calculator to solve it. I want the mean. I crossed out the others, just x bar. Find the mean. So, shh. I see some people already typing into their calculator. Please beware. I haven't told you to do that yet. I just want you to think about, read the question, and what is it asking? What does the table mean? Explain the table to me. Those numbers occur that many times. So if I want to find the average, do I need to type in 20 17 times? I could. Hang on, I could. I know there's an or, you're right. I could type in 53 times, 67 times, and so forth. We might be here till Friday, and then we could figure out the average, right? But it could be done. But there's probably an easier way, right? And there is. If you have a frequency table like we've been dealing with pretty much all day, and I ask you to find a calculation, this one's a little bit different than the plant height ones because this one was arranged, right? A little bit different. We were given bins in this case. This one we're given exact withdrawals. 17 people took out $20 from the ATM. So I can calculate an exact mean. Here's how you do it. You're going to type in the amount of money that was withdrawn into your list 1. The frequency is going to be in list 2. Go ahead and take a minute and do that, and I'll pause for just a second. 2. So we've entered the values. We're trying to find the mean. Where did we go before when we found the mean? 1 bar stats, right? So we're going to go to stat. We're going to go to calc. And we're going to go to 1 var stats. So please do that and show me what the screen looks like when it comes up. 1 bar stats. It's still 1 variable. We're not talking about 2 variables yet. So you went too fast. So when you get, that's what I'm trying to, I want the screen up that tells you what you need to do. You're going to go to list. The option is L1. You'll notice it'll say frequency list underneath that. Okay? Frequency list, usually we leave blank. But because we have a list of frequencies that we're using, we're going to tell the calculator to use it. And we're going to say L2. All this does is prevent me from entering 137 times. Can you see how maybe I might make a mistake doing that? Right? I know I would. I'd miss it or something. And then if you calculate it, you should get, what is the mean here? Did you guys get that as well? Perfect. Okay, so let's talk about what's due next class. Okay? So next class, you have a couple things due. And remember, you can leave your book at home, so you don't have to bring it back. Leave your book at home. I did find a way to bring up the book online. The first thing that you're going to need to do is I'm going to hand out a crossword puzzle that's associated with your textbook. Now, this crossword puzzle is associated with the older version of the book. So it says on the bottom chapters 1 through 6. That is not accurate anymore. It really goes through chapters. I think it stops at 5. It might even stop at 4. I was kind of thumbing through it earlier and realized that this is a little bit off, okay? They've condensed some of those chapters in this book. So I'm going to say we're going to try 1 through 5. You might not even need to go 1 through 5. You might be able to find everything in the first 4. And then the second thing is two problems out of the textbook. We'll figure out what page those are on. They are in chapter 4, I believe. It's going to be problem, I think it's page 102. I would like for you to do problems 29 and 30. These are the ogive problems. Okay, so you will be given an ogive and asked to find some things. Do not write in these textbooks. They are brand new. So I think it's a good idea to use the edge of a sheet of paper If you look back at the ogives and what we did, can you imagine if there was a corner here and you could go ahead and see where it hit the bottom? So use a corner of a piece of paper rather than draw the lines. Do you hear me? I'll be checking your books. Don't write in them. In the book. So don't write them on them in the book. Okay? So those are the two things that are due. I'll see you Tuesday. I'll hand out your crosswords in just a minute.